This case study evaluated the application of remote sensing utilizing unmanned aircraft systems. Lake Tahoe is famous for its clarity of water. However, non-native aquatic vegetation establishing along the shore poses one of the biggest contemporary threats to its trademark turquoise blue water. Pictured here are the two aquatic plant species of greatest concern for this lake, Eurasian water milfoil and curly-leaf pondweed. Each of these invaders are invaders of aquatic freshwater systems thought to have been introduced via recreational boating, and they have been proliferating along the shoreline since the 80s and 90s respectively. These maps from the Regional Management Plan show the current distribution of the two species on the right, and the map on the left shows areas of future vulnerability to introductions. These non-native plant species can often choke out novel areas in which they establish and outcompete native communities. The subsequent efforts to eradicate invasive species are often labor-intensive and costly, and so the primary goal of this work was to see if the implementation of unmanned aircraft system workflows could improve upon the pre-existing monitoring and mapping toolkit to help inform Tahoe resource managers. The primary data set used for this study was provided by the geomatics think tank, the Spatial Informatics Group in Pleasanton, California, and represented the field efforts of their staff to map various areas of Lake Tahoe in 2015 and 16. I also used traditional satellite imagery remote sensing products from the USGS, in this case Landsat 8, as well as several GIS resources pulled from the TRPA data warehouse. Broadly, two geoprocessing workflows were executed to create classified images with the goal of being able to discern invasive aquatic vegetation presence in aerial imagery. Of the 6 sites that the Spatial Informatics Group mapped between 2015 and 16, 3 were along the shoreline and within the current known distribution of one of the 2 plants. Those 3 shoreline sites are shown here, and an important thing to caveat about this study is that each site was assumed to have invasive aquatic vegetation present based on mats of vegetation visible from the aerial imagery. However, species-specific confirmation of their presence would require a site visit. The first site that we examined along the shoreline was the Run Marina, and here's the Esri base map. And on top of it is the orthomosaic image created from several flyover stills taken by the unmanned aerial vehicle. And here's the resulting image classification using isocluster unsupervised image classification. And for each site, I sampled at 5, 10, and 50 classes per each, and I decided to use 10 and use those classes consistently across the sites because having 5 classes, there wasn't enough detail to pick out different features of the landscape, and 50, there was too much noise to be efficient. So the second site shows the Commons Beach in northern Lake Tahoe, and then on top of it again is the orthomosaic produced from the drone stills. And then this is the image classification, again using isocluster unsupervised image classification. And again, these are the same classes, and you can see that the darker areas again are the most likely to be exhibiting invasive infestations of one of the 2 species. And the last site is the upper Truckee River, which is actually adjacent to the Tahoe Keys, where Eurasian water milfoil is thought to have been introduced originally. And it's actually gotten several miles up the Truckee River. So here's the base map and the ortho image that was done by the Spatial Informatics. And here's the last image classification for the upper Truckee area. And while the original intent was to compare the classified rasters of satellite imagery with that of the drone images, I actually found through this analysis that Landsat imagery isn't high resolution enough to make fair comparisons with unmanned aircraft vehicles, and in the future I would probably seek out proprietary higher resolution satellite imagery to conduct an analysis like this. But while it didn't make sense to zoom in on the sites because it was just colored squares, this slide shows the base map with the Landsat on top of it, as well as the classified Landsat for Lake Tahoe as a whole. And so the conclusions for this work was that there are indeed several ways to do image classification with unmanned aircraft systems, and depending on the resolution of the satellite imagery that you're comparing to, could be considered far superior to at least several publicly available data sets. So thank you very much.